So here we are in the calculator. It's an Excel-based calculator. I'll probably be trying to convert it to a Google Sheet so it's easier for people to access. And basically it just requires user entries, and then it uses those user entries to query the building code, and through the formulas that are provided in the building code provides outputs in the terms of reports that might be useful for designers, for code regulators, and for builders. So at the very beginning we look at the site and environmental conditions. So these are all inputs. Anything that is this sort of mauvey pink color requires an input from the user. Any cell that's currently blue is going to be a calculation that comes back. And so we'll just start. We have our site location of our building is here in Nanaimo, so we can just start typing. It is a drop-down list. So here we are in Nanaimo. And from there you can see we're already pulling back information regarding the snow load, high wind pressure, and the high wind pressure table reference. We have our site class. We had identified that on our build as unknown. So again, more information is coming back. This time it's the S max value, the seismic parameter, and the table reference. Finally here, our last input is for site exposure. Now we identified this as rough. I think I might have called it rugged, but rough terrain. There are two options, rough or open. If you're unsure what this is, there's also inbuilt README file in the calculator that I'm still working on developing fully. But basically, for some of these items, if you're unsure what they actually mean or how to interpret your site against what the calculator is actually asking for, you can click through the hyperlinks here on the left-hand side. So this one is the README file for site exposure. And it'll go through, and this line that it takes you to will identify a little bit of information about what the calculator is asking for. So user entry being required for site exposure. A description or commentary on the aspect itself. So this one we're addressing what rough terrain is and what open terrain is, and this is coming directly from the building code. And then it goes on to give you a little bit more information about what the impacts are by this selection. We can navigate back to the calculator through the hyperlink here. So you can see we're back at the landing page. Now we go on to the building design parameters. So we pulled all this information off of the PowerPoint presentation that I had before. But so we have our building dimension on our vertical axis. It was 40 feet. Okay. There's an option to enter in inches here, but you don't have to. The calculator is pulling back more information, or converting it, if you will, into metric, because all the codes are written in metric. Along the horizontal axis, we were 58 feet. Now again, these was our overall building dimensions. We had our eave to ridge height was 12. So 3.658 meters converted. The stud height here, the maximum stud height is currently set as a default at 10 feet. Lateral bracing requirements are, or Part 9 lateral bracing requirements, Part 9 lateral bracing, I should say, is permitted to be used on walls that are up to 3.1 meters, which is around 10 feet. We've got our weight of construction. In this case, we are normal. Our sheathing continuity, we have continuously wood-sheathed exterior walls. The next question it asks is the number of wood-framed floors. Now in this we have a slab on grade and then one wood-framed floor. So we select 1. Our foundation design, as we said before, is slab on grade. So you can see what happened here. By making this selection, all of these entries got blacked out for the user. So there is some interaction between the user and the calculator depending on the information that the user is feeding the calculator. The reason for that is that by selecting slab on grade, these questions here become irrelevant to the lateral bracing calculations. As we move on, I might just expand this. We're getting a matrix back here that the calculator is going to use for developing further sheets. There's no user inputs that are required. And then first off, we're getting a compliance pathway preliminary report. So this is when we was looking at the subsection 923.13. This relates to the first section. So what code compliance pathways are available to this design that we've put in based on the site location information that we've given it and the building design information. So you can see the simplified method is not permitted with this design. The calculation method is permitted. It's coming back as yes. Our Part 9 additional system considerations, so they're the exemptions and trade-offs. Are they permitted with what you have entered? And the answer to this one is no. Now, if a designer wants to look at this and determine what aspects of their design might be triggering a no or yes response here, they can link through to this code matrix. Again, it's a hyperlink. And we come through here. So this is at the back end of the calculator. It's not necessary for a user to use it. There are no entries required, but it's just useful information. We've got our location, and then elements of our design are coming back through here. So these are all essentially trigger mechanisms that apply to code compliance pathways. The code paths are referenced here on the left-hand side. So you can see our simplified approach. We are not permitted to use these approaches, and if we wanted to understand why, we could look across here and see where we're referencing red cells. We would see that our S max value, where we're designing, exceeds the trigger limits of the simplified approach table A and also the simplified approach for table B. Okay, so 1.55 is greater than these two. Also, our eave to ridge height exceeds the maximum that we can do for these two code pathways. What's interesting, at least in this case, is that the additional system considerations, so like the porch roof exemption, garage door sort of exemptions and things like that, orthogonal setback, are not permitted in the design that we have, and the reason for that is just because our S max parameter is exceeding the trigger limit for using these exemptions. Okay, the S max value can be, I'm not sure if it can be, but it is possible through the use of a professional to determine the site classification, or sorry, the site class from something other than unknown. It may be possible that this value is reduced. So for example, if I go back here, our site class is unknown, but if we were to hire a professional to determine the site class and say it came back as site class C, and we linked back here, you would see that this is now available to the designer. And if we look at this, the site class C, the S max value for Nanaimo is 1.15, and we're under that threshold. And so the additional system considerations is available as a code pathway. Set this back to unknown. So we're going to keep going through the calculator. Once we're here, we have all the information that we need to progress. The design that we're using, that I've referenced in the previous PowerPoint, does not require, at least to my understanding at the moment, any of these trade-offs, so I'm not concerned about this. But we're going to go on to the second sheet where we identify the brace wall bands. We've navigated now from the first general inputs page to the brace wall bands inputs page. And this is where the user is going to enter brace wall band specific information regarding the dimensions and the spacing. Again, it's information that we've pulled from our floor plan. On the left-hand side here, you'll see a few new terms referenced. We're looking at stories for bracing, and we're looking at bracing for walls on the level supporting. I identified these on the front elevation of our example building as our two stories that required bracing were the roof plus one floor and the roof only. Part 9 of the BCBC allows an additional floor to be designed, so a third floor, which would be identified as the roof plus two floors. And I abbreviate these through the calculator here as R, R plus 1F, R plus 2F. In our case, as you can see on the left-hand side here, we only require these first two blocks coming up as required here, not required on the left-hand side. So a kind of neat feature about this calculator is that if we want, we can reduce what we're actually looking at, so it's only elements that are where we're requiring an entry based on our design. So here we go. I've basically just reduced the calculator now. I've hidden the fields that are not required for our build. And so as we move across, we've identified this is going to be the bands on the roof only, abbreviated as R. And then we're going to follow on. So the vertical axis, all right, so the bands labeled A, B, C is where identified on our floor plan. The number of bands along the vertical axis was 3. The total distance between the center lines of the end bands, I believe it was 38 feet. The number of bands along the horizontal axis, again in our case, was 3, and the total distance was 56. And again for the floor below, all right, so that was the ground floor. In our case, these are just the same. All right, so that's all the information that is required on this page. And from these inputs, the calculator is now going to generate more granular information that is required from the designer on this Design and Feedback tab. So I'm going to click over to that. So here we are now at the third tab, or the third worksheet. And personally, I think this is probably going to be of most interest to designers. There are a lot of calculations that are required in this subsection of the building code to sort of come to a result, to understand how much bracing might be required in a particular wall. And that can be quite cumbersome because there are so many different permutations available to you. It's cumbersome, but there are a lot of options, and with those options comes, essentially complexity. The idea behind this section is that the designer can be here referencing their design and look at it and reference the required amount of bracing against the different types of bracing or different reference framing type that they're looking to install there. And so they can get that immediate feedback without having to go manually through all the calculations. So I'm going to just use a few examples here. So again, we have this filter on the left-hand side. We can filter the calculator for only those items that are required for our design. You can see it's reduced it quite a bit. So again, we've got the band ID. This has been established earlier. In this case, we have the wall supporting the roof only here, represented by the R. And then we have our band IDs that we put on our floor plan. We have the roof, the wall supporting a roof plus 1 floor, the next set, and then again the band ID or the label that we assign to them. The building dimension parallel to the band is coming through here. These relate to our overall building dimensions. And it's this dimension that is the factor for determining the amount of length that's required in a brace wall band. Our next cell is a input. You can see it's pink, and it relates to the reference framing type. This is again a new section or a new idea to this iteration of the code. It provides lots of flexibility, but there's lots of complexity to it. I won't get into it at the moment, but basically it provides a drop-down list for all the different reference framing types that are available to the designer. There's a few different ones here that I've labeled as GWB reference -2, and all this means is that this is a double GWB-A. So here is one of them. So this has drywall on one side of it. This is a wall that's going to have drywall on both sides of it. That's permitted in the code. So what the designer can do here is they can enter in what type of reference framing type they'd like to use in their band. So let's go with the first wood-based panel. So if you select a wood-based panel, you have to provide an option on the secondary bracing details. So this is going to be the interior side of what is assumed to be an exterior wall. Interior drywall on a wood sheath panel is optional. So it's coming up as optional here. And then the designer has a few different choices. They can either install the interior drywall, they can omit and block the wall, or they can omit it and leave the wall unblocked. And all of those three options have an influence on the amount of bracing that's going to be required, which is coming back here on the right hand side. As mentioned previously, there are two options that are available to code users regarding the calculation method. There is tables, or there is the alternative, which is referenced in the appendix. And there are slightly different ways to calculate required bracing length, with the alternative providing probably something that's a little bit more granular. But here they are referenced side by side for the designer. Both of them are seemingly permitted as compliant code pathways, but as you can see, they actually result in a bit of a different lineal amount of feet required based on these two inputs. So for example, if we're using the calculation method, you're required about nearly 10 feet of bracing in this band. However, if you use the alternative method, you only require about 7.5. I also input here what the design driver is. What I mean by that is that we have lateral bracing loads that are provided or created by seismic and wind elements. We need to provide calculations for both of them, and then we need to select what is the most restrictive element that we're designing for. And so this design driver is bringing back information about what that actually is. So in this case, when we're using the calculation method, it's a seismic driver, but in this case, the wind is actually the most restrictive element that we're designing for. Let's go and do another one here. So this one, let's design it. So imagine that this is going to be a drywall based. Well, let's go actually, a drywall based one. So if we select GWBD, so this is a drywall based panel, there is no option for So we've moved on now to the design and feedback tab. I believe that this is probably going to be most useful to designers as they are working out their lateral bracing designs for Part 9 buildings because of the immediate feedback that it gives and the flexibility it gives over trying different reference framing types. So again, with the last page, we can reduce the amount of lines and information that we see here, and we can filter by the items that are required based on our inputs on the previous sheets, and it just makes it a little bit more manageable when we're reviewing these things. Again, some of the information that we've previously entered is coming through and filtering through here. So we've got our band IDs, so we've got our on our wall supporting roof only, band ID is A. We've got our building dimension parallel to that band, and now we have a user input. These are the reference frame types that are available in the building code. There's a number of them that all produce a different resistance to lateral forces, and so depending on where you are and what seismic risk you're exposed to, and how much brace wall band length you have available to you, designers may have different preferences or choices here. Builders may also have different preferences on how they like to build. But in this case, we're just going to go through as an example and select WSP-A, and I'm going to pull them through as all of our bands. Pulling up more information here regarding the secondary bracing details. So this relates to what is on the reverse side of the wall of this brace wall band type. In this case, with WSP-A, the interior drywall sheathing is optional, and it's optional for three options. You can either install it, so you can install interior drywall on the opposite side of that panel. You can omit it and block the wall, or you can omit it and have an unblocked wall. And these three options are going to change the amount of bracing that is the amount of length of brace wall panel that is required with installed, providing the most resistance, and unblocked wall with omitted drywall providing the least resistance. So I'm going to change that here. I'm going to pull it through all of them. And now you can see we're starting to return some results here. Basically, I'll leave this column for the moment, but basically here we have the calculation method using the tables. We have the calculation method using the alternative method that is described in the appendix. So to my understanding, these are both permissible code pathways for Part 9 construction. You can use one or the other, and it seems like you can mix and match between them. But authorities in jurisdiction may have their own opinions and thoughts on how they'd like to implement that. But basically, from here, based on this information that we've given the calculator, we're starting to see some lengths coming back. If we look at our band ID of the roof, or the wall supporting the roof only, band ID A, we can see that for this size of building, this reference type, if the drywall is installed on the interior, we're going to be required to install approximately 10 feet of bracing length in that band. So a designer could come here, and sorry, that's based on the tables method. So the designer could come here and they could review this number against the available bracing length that they have in their plan and see if it's code compliant, or see if they could even meet that if they had to change something about the design. When we look here, we can also see the alternative method is producing a slightly reduced length. So this method actually provides a little bit more granularity, it seems, in the calculations. So that's probably why that's a bit less. The last thing I'll note is that these are all noted as seismic here. This design driver, for the alternative method is noted as wind. It's a requirement of building code that we review our design for lateral brace requirements for wind, and then we review them for seismic activity, and then we take the most restrictive of those two options. And so all this is identifying here is which of those options are actually being picked based on what method you're using to calculate it. I'm just going to go ahead and change some of these parameters so we see some of the effects that are coming through. So say, for example, that you're a designer and you actually want to put in a bunch of windows in this band, and so you don't have 9 feet or you don't have 7.5 feet of brace wall area that you can use. You can then come in here and change your reference framing type to something that is going to provide more resistance. So we move down to WSP-C, for example, and you can see that it's reducing the length that's required. The trade-off of this in some circumstances is that if you're using one of these types of panels that, let's say, is a more heavy-duty resistance component, if you're on the uppermost story, some of these require bracing into the roof system. So that's what this is pulling back here. All right. So anytime that you select a wood-based panel that is, let's say, stronger than WSP-A, so that's going to be B and down, you're going to require to continue that bracing into the roof system if it's on the uppermost floor. Blacked out down the bottom here because these are the walls supporting the first floor, so obviously they don't go into the roof system. Based on our inputs now, the calculator starts to produce a number of reports for the user, and these may have different benefits for a bunch of different user groups. The first one that we'll look at here is the length compliance report. Again, it can be filtered by the fields that are required and not required. And it's a pretty simple report that basically outlines the lengths that are required for a particular brace wall band. If we're using the table method, the tables calculation method, or the alternative calculations method, these will be displayed in feet and inches and 1/16 of an inch, which is pretty typical for things like manufactured truss products. So your builders and framers should be comfortable with this. There's a user input option over here so that the designer would be able to input the cumulative total of bracing that they have applied to their lateral bracing design on their building. There may be opportunities with this to expand it a little bit further to include individual panel lengths. I'll probably look at that a little bit in the future, but for the moment, we're just looking at the total length of bracing. So the intention here is pretty simple. It's just a way to visually represent whether you are passing a code compliance check, whether the tables method or alternative method or both are applying to that pass or fail. So for example here, if we take our first brace wall band, it requires nearly 6 feet through the tables and about 3 feet on the alternative. So if our system had 4 feet of bracing, we would be passing on the alternative method and failing on the tables method. This would be a pretty simple report to print out and provide your building official at your building permit application. And it'd be a great way for them to just very quickly get an overview on the different bands that you are passing and failing on, for example, and in which way. Say, for example, that the designer happens to get to this point and you realize that you only have 8 feet of bracing, and that is not enough for this band. The idea here is that you probably wouldn't get to this point, you'd probably be aware of it already, but if you wanted to, you could jump back into the design, R3, and you could change this element to something that's a little bit stronger. And then you would start to receive the passes back here. The next report that comes up is the adjusted lengths report, which is based on the tables calculations. Again, this is going to be another great report for building officials. This outlines pretty clearly all the different factors that are applying to the calculation method for your particular design. There are lots of back-end calculations that take place in this calculator. There's a lot of interpolation that takes place related to the building code tables, and all the results of those calculations are published here in one straight table. As I said, this one relates just to the adjusted lengths that are produced by the tables calculation, but we have a similar one that produces a report that is based on the alternative calculation method that's outlined in the appendix. So again, they require different parameters, but all those parameters are here. And if you're a building official at a plan check, this would be really handy because you'd be able to really quickly identify the values that have been used in the calculation process. So finally, we're moving on to our last set of reports, which are called the construction reports. And it should be obvious, but basically these, I think, would be most beneficial to builders, but they're also going to be, I think, beneficial to building officials who are doing building inspections on site. The content of these reports relates to construction requirements, in particular nailing patterns or the amount of nailing that's required, but also pulls information related to the inputs that we've made on previous pages into sheathing requirements, what type of sheathing is required, and we'll get into all of that in a minute. On this first page though, we are presented with some inputs that are required related to builder preferences over fasteners. The fasteners are going to have an impact on or the selection of fasteners is going to have an impact on how many fasteners are required for a specific connection, and the spacing of fasteners when we're nailing off brace wall panels. So I'm going to go through and make some selections here so we get some inputs. We're particularly concerned with the diameter of the nails. So with this one, for wood-based wall sheathing not in brace wall panels, I've provided an option to reference what we've previously selected for nails in brace wall panels. The idea behind this is that a framer may be more efficient or may be more comfortable using the same nails for brace wall panels as they are for the rest of the sheathing. And the same thing could be said for when we get down here to subfloor sheathing fasteners and the roof sheathing fasteners, but I've got a few more to put in here. So yeah, as I said, when we're looking at wood-based roof sheathing fasteners, there are lots of options that are available to builders and framers, but typically, in my experience framing, it's nicer just to have one box of nails on site to alleviate any concerns of where particular nails should be used. So the options here are that the calculator can make the adjustments to the building code based on one set of fasteners. So then we go through this report. It started to pull back information for us. Again, this information is going to be pretty typical for builders or framers to understand. We come through here, we've got requirements that relate to lateral bracing systems and framing connections. We're looking at specific connections that are called out in the code, the spacing requirements on center spacing in inches, or the number of nails that are required. The same thing applies for the subfloor sheathing, the wall sheathing, and the roof sheathing. Again, we've got another little bit of a filter that is applied here. There are some instances where the roof sheathing has a couple of different options depending on what has previously been entered. So that's the first phase. The second set here, I'm just going to zoom out a bit so we can see it. Be able to see. Again, I'm going to filter when required. So this report is primarily concerned with our brace wall panels and our reference framing types. So on previous pages, we've entered in reference framing types that are assigned to a particular brace wall band. And here, the calculator is pulling back all the information that is required to actually build these things, or all the pertinent information at least. So each reference framing type comes with a host of different construction requirements, be it how many anchor bolts are required, or the spacing of anchor bolts, what the panel sheathing must be, if it requires blocking, and then of course the fasteners, if we're using a particular type of fastener, how closely does it have to be spaced? We're looking at panel nailing, so we're looking at how far apart do those nails need to be spaced on the edges, and how far apart do they need to be spaced in the field of the system. So here we'll just take one example. So we have this top line here where it's the band ID is the wall supporting the roof only, number A, or letter A. The reference framing type is WSPD. And it goes through, it tells us how many anchor bolts are required per panel and the spacing of anchor bolts in those brace wall panels. It tells us the maximum stud spacing. We look at the double top plate nailing, so the minimum lap that's required in that brace wall band, how many nails are required on each side of that lap, is the bracing extending to the roof top chords? In this case it is. And then we look at the sheathing requirements. So this is the primary bracing sheathing elements. It's going to be on the exterior typically. The thickness of the panel that's required. Horizontal blocking is required in this case. The type of fasteners that we're using based on the builder preferences, and then the spacing requirements on the edges in the field. As we move along, we have the secondary bracing system. So this relates to other inputs that we've provided previously. So there is a reference framing type for interior drywall, and it's GWB-A, and it relates to half-inch gypsum. Does not require horizontal blocking. We've selected by builder preferences that we're going to be using drywall screws, and then it provides the on-center spacing for the edges in the field of those drywall panels to be installed. I'll see if there's a couple other examples here to pull out. Not really at the moment, but as you can see, there's lots of variability in depending on what reference framing type we've decided to use. There's also variability in whether we've selected to install or omit a secondary sheathing. So if I come back here, just for a quick example, back to the design and feedback report, here we have secondary bracing installed on all of the panels. But let's say that's not typically installed in the garage, and our garage, just hypothetically, is panel, is band ID at the bottom here. So we're going to remove that interior drywall, and we're going to unblock the wall. So if we come back to our construction report, the last one here, so you can see now that it's coming through that the drywall is not required here, and that all these fields are grayed out because there's no actual construction requirements that are required on the interior there if we're selecting to omit and unblock the wall. So that's it from me. Thank you very much for listening and potentially watching this demonstration. I know it's been a little bit long-winded, but there's a lot of information to get across. Hopefully it's helpful. If you have any feedback or questions, please feel free to reach out. I'd be interested in